My name is Jeremiah Grossman. I am the founder and CTO of White Hat Security. I've been doing web security a long, long time. Probably before web security was actually a term that anybody used. For those that remember way back when, we used to do CGI programming and we used to do CGI security. That's where I started. And I'm going to give you a presentation, just kind of the basis of my career and different ways to address web application security at an internet-wide scale. Before I get into all that, just a little bit of my background. I've been doing web security-like stuff for the last 15 years. Was an information security officer at Yahoo many, many years ago. I got to experience one of the first ever mass DDoS attacks, the one that targeted Yahoo, for those that remember Mafia Boy. Given presentations all over the world and just try to share what it is that I know, or think I know, and things that I've learned. For the last 10 years, I've been doing White Hat Security. So White Hat, just so you know where I'm coming from here, is a software service platform for conducting web application vulnerability assessments. Our customers hire us to assess the security of their websites, find the vulnerabilities, and help them get them fixed before the bad guys give them a really bad day. And it's been happening a lot out there to everybody. So I'm going to share with you data on that stuff. Man. All right. Let's talk about the size of the web here. The size of the problem that we're dealing with. What I think about most days is right now online, as per Netcraft, that's about the number of websites that we have to secure out there. Well, maybe not have to secure. A lot of these are spam websites, blog websites, SEO websites, and things like that. But right around 677 million websites online, growing somewhere between a few 100,000 to a few million new websites per month. It's big. What are the websites that are least important, the number of them? I like to break this down because we don't have to secure the entire web, maybe just the important websites. So right now there's about 1.8 million websites that have SSL certificates on them. SSL is an indication that the website has something worth protecting, otherwise why would you buy a $50 cert? So it's at least that number. To give you an idea though, the real number of the websites that we have to protect are between this number and the 677 million number. Just to give you an idea, of the sites that White Hat is assessing every single week, about 20% of them are SSL enabled, the other 80% are not. So the number is between the two. It is a staggering number. We are clearly producing more code than we're able to test, whether it's in dynamic analysis when we hit production or static analysis prior to. We have a whole lot of software out there. Let's get some numbers here so we understand the gravity of the problem. It's one thing to have a whole lot of code. It's quite another to know what vulnerabilities are in the systems or how many. So let's give you just some quick highlights here. 8 out of 10 of the websites out there that we have tested, and these numbers are fairly similar to our peers in the industry, have serious vulnerabilities. Let's define serious since I put a little asterisk on it. These are the vulnerabilities that you can exploit to take over some or all of the system, get access to data that you shouldn't have, or take over the user's account. The things that will make you headline news and the vulns you really don't want to have. Websites are also 24/7 operational businesses. You don't get to hack it on one particular day and go away. These are 24/7 businesses, so it's helpful to know how many vulnerabilities are in these systems, let's say, in a given year. And these are the numbers. In 2007, we were finding roughly 1,100 vulns per website per year. It's also helpful to understand how it is that we count. If there is, let's say, login.cgi, login.asp is probably what we're thinking about here. Let's say 3 of the 5 parameters in that web application are vulnerable to SQL injection. That's 3 vulns, the way we count here, and not 5 and certainly not 1. Each parameter that's vulnerable is a unique vulnerability because it probably goes to a unique line of code. So 1,100 discrete ways back in 2007, and the numbers started to go down substantially all the way down to 2011 where we had 80 discrete vulns per website. So we're making progress. That's a good thing. What I can't tell you right now with any kind of certainty is that if our numbers are representative of the other part of the web. We have a very, very biased sampling at White Hat because the people who come to us probably care a lot about their web security programs, probably put a lot of emphasis on it. So we might actually represent the more secure part of the web, and everybody else is probably substantially worse. So that's the volume that we're dealing with, the number of vulns out there. Let's do some guerrilla math. 1.8 million SSL websites times 79 vulns per year gives us about 142.2 million vulns. Million O days. These are not CVE vulnerabilities that you can patch with Microsoft or Oracle or something like that. These are unique custom web application vulnerabilities that have to be fixed on a one-off basis. We are not going to fix the web one vuln at a time, anytime soon. This is a monstrous problem. For those that are in this particular session, you probably have a few websites, probably a few dozen or a few hundreds, and your numbers are representative of mine. So how do we fix this number of vulnerabilities out there? It's a massive, staggering problem, and the bad guys have been making us pay. In the last 18 months, this is just a small sampling. I could probably put another logo up here today on the amount of websites that are getting hacked out there. It's everybody from colleges to oil companies to retailers and banks. Nobody is off limits anymore. Gone is the excuse that why would anybody want to hack us? You know, we have nothing special. Everybody has something to steal, and if you have nothing to steal, your websites will do, because your websites can get infected and to compromise the users or the visitors of those particular websites. But just look at the numbers. Let's just take the privacyrights.org numbers here, and there's lots of numbers out there. SQL injection was the means used to extract 83% of the total records stolen in successful hacking-related data breaches from 2005 to 2001. We're dealing with a web security problem. Buying more firewalls and more antivirus is not going to solve this problem. That's all there is to it. But I get, as a vendor perspective, I get extremely jealous when the world spends $12 billion annually on buying antivirus when we know for a fact it doesn't work. So I'm going to show you some numbers here. I'm going to go over this as the service that we provide. But basically, we're assessing websites all the time, and we're verifying results. So the numbers that you're going to see from me here next are the ones that are validated as accurate. Just a bit about the platform. We're doing tens of thousands of assessments all the time. These numbers are representative of 500 plus companies from startup to the Fortune listed, and we're processing about 7 million vulns per week. Not all of those are real. We have to weed out a substantial amount of false positives before we report, but just gives you an idea of the work that we're doing internally. I can give you the 79 numbers, the average for the world. If you say the average website has 79 vulns per year, that's fine, but the average doesn't tell you very much. The averages get all over the map. Well, it tells you more, I should say, when you look at it by industry. So if you look at the banking sector, if you're a bank website, you have 17 vulns per year, or about 1 per month. If you're an online retailer, it's roughly a 121 discrete vulns per year. So it's vastly different between the two. Couple of things to note. The retail sector, which has a lot of compliance spending based upon PCI. If PCI works, I can't see it in the numbers. Banking also is heavily regulated, but it's government regulated, not industry regulated. For whatever the reason, that might be one indication of what actually works. Now, I'm not advocating for government regulation, but it seems to be that government regulatory systems actually perform better than the private sector regulated ones. Then we have other ones, such as energy, that's pretty good at 31. But these are vuln volumes. One of the reasons that retail might be different than banking is the retailers actually might push code much more often and give themselves new opportunities to introduce more vulnerabilities than the average banking website, which might change only a couple of times per year. So that might be one indication of why life is not fair for the retailers. I've given you volume, haven't given you type. This is our top 10. It's a little bit different way to look at a top 10. If you look at the leftmost number here, cross-site scripting, it's 55% of the sites that we looked at in 2011 had at least one cross-site scripting vulnerability in them. 53% had at least one form of information leakage, vulnerabilities such as anything could be internal IP addresses that leak out, software version numbers that leak out. And we've even found occasions where you view source on a web page and you find back-end database usernames and passwords. It happens. Down the range, though, and I want to point out one of the ones here, is in the pink, that's SQL injection. That's the big baddie out there. It's at 11% of websites. Roughly 1 in the 10 websites that we look at right now have at least one SQL injection vulnerability. It should be painfully clear at this point that vulnerability prevalence does not directly map to exploitation. 1 in 10 websites, that right there is what's causing us all the pain. So the lower end of the range is what's causing us a lot of pain, not the issues that are most prevalent. I can only share with you what's possible. The bad guys are in ultimate control of what's probable, what you can exploit. Here's the time to fix, and I mentioned this last year, and these numbers are way better than they were the year before. So I think this laser works. Probably can't see it from where you are. I want you to follow the black line up, right in the middle there, to where it hits 50% on the vertical. That's half of websites. And when it crosses over the 50%, you draw a line down. What that means is most companies are fixing their website vulnerabilities in 38 days or less. That's much, much different than it was in 2010 at 116 days. So if you want to be better than average in your web security programs, you aim for 38 days or faster. Give yourself a month. If you want to be a leader, you get 2 weeks. That's what you should be targeting your web security programs as. If you want to be the best of the best in, let's say, banking, right? Banking is, let's say you want to be in the top 25%. Again, you got about 2 weeks to do it. So it kind of gives us an idea of how fast the vulnerabilities are being fixed out there. The other thing to keep in mind is just because we find vulnerabilities doesn't mean they get fixed all the time. This is the one I track very, very closely. This is our remediation rate. It's all well and good to find a vulnerability, but it's quite another to actually get issues fixed. Back in 2007 in October, the average number of vulnerabilities that were getting fixed in a given year was roughly 35%. Right now, it stands at 63%. So we've been making progress. So 63% of the vulns we're finding are getting fixed, but it's increasing 7% or so year over year. So we're making progress. We're getting a little bit better at fixing these issues, or the bad guys are forcing us a little bit better than they once were. Any questions so far on these numbers? You sure? Okay. Now, the amalgamation, the total collection. How do we measure website security performance? What is, the one key performance indicator? I like this one. This is the overall window of exposure. This is the number of days in a year a website is exposed to at least one significant vulnerability. And this is important because the bad guys only need one vulnerability to win. Top left, 29% of the websites we looked at throughout the duration of 2011 had at least one publicly exposed serious vulnerability every single day of 2011. That should be quite sobering. On the other end of the spectrum is 30%. 30% of the websites we looked at had a serious vulnerability less than 30 days of the year. So when I want to learn about web security, I want to learn from my peers. I want to learn from our customers. I want to learn what the guys in green are doing that the guys in red are not. And that's where we're going to start making actual gains. Let's get away from the generic best practices. Those aren't doing anybody any good. And figure out what is actually working in these organizations. And I'm going to start pinging on this stuff because I'm going to come down very hard on generic best practices because I'm going to have actual data to back this stuff up. All right. Scaling web security programs. You have a lot of websites, you have a lot of developers, and you have a conflict of interest between the business and development. Development wants to push revenue-generating features. Security wants to slow that down and allocate resources to fixing vulnerabilities that may or may not get exploited and may or may not cost the company money. What we have found is that when you reduce the time between when the developer writes a vulnerable piece of code and when you get the data back to them that it says this is a vulnerability here, you get vastly different time to fixes and remediation rates. So if you take a developer and say, they have just written a SQL injection vulnerable piece of code, and you tell them, you know what, within a week of time, you tell them, there's a SQL injection vuln in the code you just wrote. It's going to take them roughly 15 minutes to an hour of lost productivity to fix that issue. You take the same scenario, but for whatever the reason, you don't communicate back that they have a SQL injection vulnerability in their code for a month, their time balloons to 1 to 3 hours to fix the code, or a day of lost productivity. Because they're not, mostly because they've been tasked elsewhere. The code isn't on the screen anymore. They have to go refine it. It's a familiarity issue. If you wait over a month to a year or more, it is actually 2 to 3 days of lost productivity because the developer has moved on and the software is now in maintenance mode, and the person fixing the vulnerability is not the one who introduced the vulnerability in the first place. So the faster our testing, the faster we iterate, the faster we're able to fix these issues. This is very, very helpful to understand. Now let's talk about scalability. So we've laid some of the groundwork here. That's the name of the game in web security because our problems are big. I think I killed the battery. All right, so scalability, definition from Wikipedia. Let's just move on past this stuff. All right, so I asked this question on Twitter. What does scalability really mean? And I kind of mentioned that it might somehow getting other people to do the work that we think is important, and Adam Shostak had a much better answer. It's automate or delegate everything you possibly can so you can add unique value. That's a very big deal. If your work can be automated, it probably should be, because it will be automated eventually, and let's focus on the stuff that the humans can do extremely well. I think that's part of what Win Schwartz was getting at. We have to provide unique value. There's something special about the humans in this industry, and we have to focus on that and let the automation take over everything else. So scalability, how I define it from a business process standpoint, it is the combination of people, process, and technology. Only when you get all three do you get something that scales. When you buy a software component, or not, I should say buy a technology and you don't work it into your business process and you don't have the people to run it, you won't get scalability, you'll get shelfware. So what are the three hard facts about technology, especially in web app sec, that people miss? Technology is incapable of eliminating the need for people in any aspect of application security. This goes for scanning websites, finding vulnerabilities in code, developer training, and so on. We need people for everything that we do. Without technology, on the other end of the spectrum, without technology, there's far too much work that it could ever be completed manually by the number of skilled people we have. We're going to get to that part. We're going to go faster because this is really slowing me down. We're going to gamify here. So we're going to go through 7 different things on way you can scale your AppSec program. We're going to go through gamification, making things fun for people, particularly developers. All right, elevation of privilege. Who's familiar with this card game? Really, nobody. Excellent audience. Go to this There's a website here. This is a game from Microsoft developed by Adam Shostak. It's a version of Spades. It's a way you can actually get this card game and go to your developers and ask them to play a game with you, and maybe they even start playing amongst themselves. And they play this game and actually indirectly start learning about things like spoofing, tampering, repudiation, information disclosure, and so on and so forth. It's a way to gamify the education process for developers. It's very useful, and I'm told, because we use it internally, of relaying or articulating these concepts to others in a fun and educational manner, rather than just giving them a chart and maybe a list of test questions and say, here, learn their stuff. We learn and we play together and we try to win. Very fun. If I stand over, okay, capture the flag. Capture the flag, another really cool way, we do it internally. You guys have obviously heard of capture the flag games. Participate in them. They're really, really fun. There's all different kinds of ways. We have the benefit of internally where we use the web to do capture the flag, where we bring up a new, supposedly super secure website, and our army of web hackers descend upon it, and I actually will put down $500 of my own money to see who can hack it first, and it's never lasts more than 20 minutes, so I'm usually out $500 in 20 minutes. Then you have peer pressure. Next one, peer pressure. This is a really cool one. You develop scorecards internally. You develop metrics internally on the areas that you want to improve upon organizationally. What you do is you find your metrics, your high severity vulnerabilities, your time to fix, your remediation rates, whatever. You can do it by patches and uptime and infection rates. And then you start measuring these vulnerabilities or these security metrics by business unit, and you publish them internally, very similar to this internally. It has a very, very interesting and very, very powerful side effect. What happens is those that rise to the top actually get recognized for being the most secure business unit in the entire company. And those that are the laggers get called out very publicly. It's kind of a name and shame kind of thing of those that aren't doing so well. And what happens is it changes the conversation between the underperforming business units and security. The underperforming business unit will then contact security and go, how do I improve our numbers? They come to you rather than you having to go to them, because no one wants to be the low guy in the totem pole. Then you have the computer-based training. Obviously, trainers are at a premium these days. The people that know web app sec are really hard to come by, especially those that have, what did Win Shui? We kind of have an overabundance of ADHD and what was the other term he used? Asperger's. And getting enough of these people that can relay information and teach others these things. So we need computer-based training. Because here's the numbers. This is the biggest problem in AppSec today. It's the huge shortage of qualified application security people. And I like the way the OWASP organization breaks down the different application security professionals into builders, those that can help build secure applications, the breakers, those that can actually point out the flaws in secure applications, and the defenders, the ones that look out for incoming attacks and try to defend the business operationally when it's all said and done. So let's look at some of the numbers here. Gary McGraw, CTO of Digital, he does a study called BSIM, and it looks at different large-scale software security programs and how they perform. Not necessarily what they work, just what they do. And he finds that software security pros, as a percentage of overall IT, represent 2%. So 2% of the software of the IT programs represent software security people. So if you have, let's say, 1,000 developers, 2% of them will be software security pros. So if you look at the worldwide population of developers at 17 million, we're going to need 340,000 software security pros. I just came from AppSec USA last week, which is the world's largest application security conference, and we had 800 people show up. It's a huge, huge gap. How many people here are hiring application security people? The rest of you are lying. I know you're all hiring them. Yeah, with HP's hiring, trying to hire them. The breakers category, used to use White Hat's numbers. Let's say we had to look at the vulnerabilities in 1.8 million SSL websites. Right now, White Hat has about a 1 to 100 ratio. You need collectively one breaker to assess 100 websites per year, let's just say one time. So that means we'll need 18,000 breakers, 18,000 people that can run scanners and verify vulnerabilities and sanity check the results. We have nowhere near that many. We might have 2,000 to 3,000 worldwide, maybe. And then defenders, those that look at incoming attacks and try to defend against them. Those that try to weed out of the 1 billion users the undesirables. I have no idea how to guess this number, but it's a lot. It's probably currently the guys in the NOCs and the SOCs that are looking at the blinky red lights that we have to convert over to Web AppSec. And I don't know how many we're going to need, but it's going to be a lot. Another probably tens of thousands more. So we got a hiring issue. So one of the ways is computer-based training, and one of the examples I'll give you is the OWASP AppSec tutorial series. There's tutorials out there that you can send around to your developers or send around to your security teams even on how to learn web security issues. So look at this right here. So Jerry Hoff, he used to be a trainer, on-site trainer, training developers of maybe somewhere between 10 and 30 guys. He develops a SQL injection video, 10 minutes long, tells you all about SQL injection, what it is, how bad it is, how to exploit it, how to fix it. And on YouTube, he's able to touch 30,000 people. He would never have ever done that. So we need a lot more of this in web security, and maybe all information security, on how to digitize our education and make it into small, bite-sized chunks that get, that become usable. Next one, centralized security controls. You can have developers going, well, this is how I've solved SQL injection, and other developers, this is how I solve cross-site scripting, and they all do it differently, and they all do it wrong, or we can start centralizing our security controls. One of the examples that I'll show you is with something called the OWASP Enterprise Security API, ESAPI. It's a way to centralize security controls that say, if you want to read data from a database or write to it or write data to the screen, you're going to go through this centralized framework here because it's done right. If for whatever reason it's not done right, you can fix it in one spot. And you get scalability across the organization because not every developer needs to know, how to parameterize SQL. Say this, you read data like this, and you write it like this. You use this API, and there's no other way to do it. So you centralize this stuff, and you centralize the knowledge, and no one has to think about it. This is just how you do it. And this has actually been quite helpful. A couple of years ago, I actually measured the security differences between sites that are running, let's say, Java and .NET versus PHP and Perl. And what I found was the new managed languages are about 20%, quote-unquote, more secure than their predecessors, which is good. The downside is that the developers didn't, when they found a SQL injection vuln in their code, when something bypassed the control, they didn't know how to fix it, so it lengthened their time to fix Windows. But it's better overall. Then you got workflow tracking. There's a particular company out there called SD Elements. They're creating a methodology. They're rationalizing a methodology for application security development throughout the software security lifecycle. Rather than just picking and choosing stuff, what you do is you create a profile for your application, what type of application this is, what are the components, what type of data it has, and it starts working you through controls that are needed for this application to be secure, and it starts allocating tasks that developers have to complete. So then you have a checklist. It needs this control. Developer goes, okay, I added this control, and there's a checklist. So they know what to do and when to do it. Very cool stuff. So I see the task there, bind variables and SQL statements, so on and so forth, or use direct offer references matches to accessing of files. So they have all those things. If this is what your application does, you have to make sure you do it this way. And it gives you all the information that you need. Very cool stuff. There's another one, Risk.io here. Risk.io. So if you're in an organization and you're dealing with vulnerability data, you might be dealing from White Hat, you might be dealing from Qualys, you might be dealing from Rapid7 and a whole bunch of companies. And there's no central way to, or central repository. So there's no way to, its scalability is tough because you're looking at multiple different screens. This company here is starting to combine it all together and creating a master list, a source of record for all data across the organization. So again, it's allowing the security expert to automate away all the mundane tasks so they can start looking at these things at a strategic level and going, where are vulnerabilities and what do we have to do first? So this is the more of the technology that we're going to see coming. Then we got virtual patching. So we got a lot of vulnerabilities out there, more than we're ever going to fix in the code, and I challenge anybody who thinks otherwise. One of the things that we find, at least in our data, others might have different data, is about 50% of the vulns that we find in total are cross-site scripting, 14% are cross-site content spoofing, 4% are SQL injection. If you tally up the vulnerabilities that web application firewalls tend to be good at fixing, it's about 71%. So 71% of vulns can technically be mitigated in some way, or at least raise the bar of exploitation. 71% we could deal with that way, and the other, let's say 29%, we can start solving in the code. So it's a way to reduce down the workload while giving us some help right now. Then the last one, bug bounties. My personal favorite, save the best for last. Crowdsourcing vulnerability assessments. All right, so how do I describe this? So bug bounties have been around forever, but they're mostly been in software. But I'm going to talk about the website variety. So hacking systems that you don't own is illegal, but only if the system owner didn't give you consent. When you give consent to people, it then becomes not illegal anymore. So what these companies have done, and now there's a lot of them, there doesn't used to be any of them, these companies now allow anybody and everybody who wants to hack their websites. Right? Anybody who wants to. You're not going to go to jail by finding a vulnerability in twitter.com or ebay.com. They welcome it. Provided if you find something, that you give it to them discreetly so they have an opportunity to fix it. After that, you can do whatever you want. There are now 5 companies now, because Etsy just started a bounty program, that will actually pay you rewards for finding of vulnerabilities. That's Google, Facebook, Mozilla, and PayPal. You find a vulnerability. In the case of Facebook, you find it's just a simple cross-site scripting vulnerability, and anywhere in facebook.com, you get $500. If you find one in Google's Gmail, they'll probably give you $2,000 to $3,000. Google has actually been giving people $60,000 for hacking of Chrome, but that's software. So anywhere between $500 and a few $1,000s for finding vulnerabilities in websites. So again, I was at AppSec last week, and there was actually somebody there who paid their way to get to AppSec from India based upon bounty money he got from these particular companies. Collectively, these guys have, in website bug bounty money, have given away over $5 million, and more coming on every day. So Etsy, a retailer, just joined the ranks. So this is an area to watch closely, because here's the way it works. How does this scales? Because for an application security expert, for those that call themselves an expert, you have to be able to find most of the vulnerabilities and not all the vulnerabilities in any given website. But what happens is when you crowdsource it, any one particular person could probably find one in PayPal or one in eBay or one in whatever these companies. So you get this long tail. So what happens statistically with these guys is their best bug hunters tend to clump between them. The best bug hunters will actually find bugs in all of them, but there's a ton of people out there that have just found one across the range. So it's been a very interesting model. I think our US government, or any government for that matter, can actually benefit by this particular model. What are we gaining by not allowing the good guys to hack into .mil and .gov systems much the same way that these guys do. What are we gaining by that? We're only not allowing the good guys to help. I know it's a very controversial idea, but give it time. Imagine if certain GOV or MIL systems that say, yeah, here's their sites, come find vulnerabilities, let us know, we'll pay you cash. It might ease their burden on the hiring process as well. These guys have all hired people that have found bugs in their websites because it's can you or can't you. It's a meritocracy. So you've made it through all 7. How am I going to spend my year? I'm going to back into this. I got 2 more slides here. You have BSIM, Build a Software Immaturity Model. This is how they say how you can map, how you can measure your software security program relative to your peers. If you go to Microsoft's, you get this one along the bottom. You get this one from OS. This is how you build secure code. But if you really ask the tough question of the people who advocate for this stuff, if you ask them, does any of this stuff work? If I invest all this money in doing an SDL, does my software get more secure? Or rather, do I become less hackable? There really is not a whole lot of data to back up this stuff. We really don't know what works in software security. We can certainly spend a lot. We can certainly say developer training is a good idea. Source code reviews is a good idea. But it may or may not be a good idea for everybody at all times. So here's what I'm doing here. So this is how I start mapping things. You have the things you can do in the software development lifecycle, and then you start measuring security outcomes. So right now I have about 6 years of software security outcomes. Like I have 6 years of vulnerabilities in websites. What we don't know, what we are blind to, is what the organizations did internally to get there. So I don't know if they did developer training when and how it affected the outcome. So that's actually going to be my 2013, is to start measuring what companies did and when and how it impacted their software security program, positive or negative. I am convinced that certain best practices are only applied on a one-off basis. So to give you an example, I give you website A. Website A, let's say, has 10 vulnerabilities per year to make an extreme case, but their time to fix is really long. So they low vuln counts, time to fix is really high, remediation rate is really bad. Low vulns, low time to fix, low remediation rate. Now, if you tell them that they're going to introduce developer training to try to lower their vuln counts or improve their metrics, it's probably not going to work. The developers are doing a good job when it comes to vuln volume. But what the business does not seem to be doing is prioritizing the bug fixes so things get fixed faster. They're probably generating revenue-generating features. On the contrary, let's say you take another website that has a whole lot of vulns, but when there's vulns, they fix them fast and they fix them often. They probably need developer training, or they need a centralized security framework. So that you start taking the extreme cases and you see how well this stuff works. I'm going to start mapping these things. Now, I'm going to find vulnerabilities that are possible. The guys that are measuring attack traffic will tell us what's probable. So they can take my vulns and prioritize them on what the bad guys are actually using. If the bad guys are actually using cross-site scripting and SQL injection, then whatever the vulnerability prevalence is, target those first. And then this brings us to breaches. Whatever the bad guys are using, when the incoming attacks are coming in, block those first or pay more special attention to there. Right now, all of our data is siloed and no one talks to each other. Probably because we don't have a lot of data in all of these silos yet. We're still coming up to speed. But once we can start tying these, we're going to get very strategic on our web security programs.